The second part of section 7.1 is we are going to continue using our trig functions, and we're going to use the identities that we've used before. This first example, however, is just getting you used to figuring out whether sine and cosine are positive or negative no matter what. All right. So when you find the sine of 765, is that going to be positive, say 1/2, or square root of 3 over 2, or is it going to be negative? So what we're doing, we're saying to help us work on that, we're going to express each value as a function of an angle in quadrant 1. All right, so basically, if we figure out that this sine ratio is supposed to be negative, we're gonna write it as a negative sine of its reference angle. And if it's going to be positive, we'll just call it the sine of its reference angle. So what we need to do is we need to find this guy's reference angle, and then we're going to indicate whether the sine function is positive or negative. That's basically all it's asking for. So first off, we got to figure out where the angle 765 is. So as I go around my circle, if I go around once, that's 360. If I go around twice, that's 720 degrees. What I have left, all right, is 675 minus 720, all right, and I have 45 degrees left, all right. And so my angle's right here. Basically, they're saying express this thing as a function of an angle in the first quadrant. This angle is in the first quadrant already, so and then we know that the sine ratio is going to be positive. Opposite, this over here is positive, and the hypotenuse is always positive. Positive divided by a positive is a positive. So we're going to say, expressing this function as something in the first quadrant, we're just going to say it's sine of 45 degrees. And that's it right there. It's going to be positive. If it were negative, say it ended up down here. All right, so here's our new angle is down here. Okay, then we know that the sine ratio is going to be negative. We would just, and this is a reference angle of 45, we'd say negative sine of 45. Anyway, I'm sure that'll come up here as we continue to go on. It says the cosine of negative 135. Well, we got to figure out where that negative 135 is at. Negative indicates which direction we're going. Now we're going this direction. If I get to here, I'm at 90 degrees. I can't go another 90, so it's going to be in between here. All right. So we're asking this reference angle. If this is 135 degrees, this leftover to get to 180 would be 45 degrees, correct? So now it's asking us to express this thing as something from an angle of quadrant 1, which means that's why we're using a reference angle, by the way. All reference angles are in quadrant 1. Okay, so we're going to say, well, the reference angle is 45, so it's going to be the cosine of 45. And is the cosine value going to be positive or negative? Well, cosine is adjacent, which this is a negative value, over hypotenuse, which is always positive. So a negative divided by a positive is negative. So what we write in our answer is, this function is then negative cosine 45. This is telling me if I want to know the cosine of negative 135, it's going to be the same thing as negative cosine of 45 degrees. A lot of times dealing with angles in this first quadrant is so much easier for us. So if we learn how to write it this way, we help keep our negatives intact. All right. And then this last one, the tangent of 315. All right. So the angle 315 degrees is way over here, right? Not quite 360. Again, we're going to use this reference angle. And in order to get to 360, this distance has got to be 45 degrees. This angle is 45 degrees. Now, they're not all going to come up 45 degrees. For some reason, we chose angles that are always 45 degrees. Anyway, so now they're asking, is the tangent, express this tangent function as something from angle quadrant 1. So it's going to be the tangent of 45. And now is our tangent function going to be positive or negative down here? Well, if I go over here, this is a negative value. Opposite all over adjacent is tangent. All right, negative divided by a positive. This is a positive direction. This is negative direction. So to make it that function, it's negative tangent of 45 because this would be a negative value. That's all that's looking for. Okay, so here's what I'm going to do for this. Example 2 says use your trig identities to simplify the following equations. A lot of times when we're doing this, it's helpful to look at your trig identities to see what we can use. I'm going to pause the video real quick and I'm going to zoom in for you here. Okay, so far these identities over here to the right side in this right page over here, all the ones we've talked about in the last video and that we dealt with in our last assignment, tangent and cotangent identities, reciprocal identities that we've talked about, and the Pythagorean identities that we've talked about. Okay, so I'm going to keep those on the left side so we can see, and we can see our options. Knowing what we can replace things with is key. So now we're looking at, all we're doing is we're going to simplify. We're going to use our algebra to simplify is what we're doing. Okay, so what I noticed out of these two is I noticed they both share a sine squared. All right, so look if you can pull anything out. I know I can pull out a sine squared, right? So let's pull a sine squared out to the outside. Just like if you were to have x squared plus 4x, and they ask you to solve, well, you pull an x out, right? They share a common term. So we're going to pull a sine squared out. And when I pull a sine squared out, it's like dividing by sine squared. Sine squared divided by sine squared is just 1. If I take a sine squared out of here, I'm left over with tangent squared x. All right? Well, you might think if you have 1 plus something or something squared, you might want to look over here at our Pythagorean identities. Notice that they're the only ones that are squared. So if you have something squared, Pythagorean identities are good to look at. So if I look over here, do I see anything that has 1 plus tangent squared? I see one right here. This is going to be secant squared. So instead of having tangent squared plus 1 or 1 plus tangent squared, remember we could write these in any order we wanted to. I'm going to write secant squared instead. I'm just going to substitute in, and that might help us. All right, and sine squared. Or I changed it, I don't know why I changed it to theta x, same thing. Both variables, okay? Cross the lines here. And I still think it's a little bit messy because I know I can change secant into something else. I know I can, instead of secant, I can write that as 1 all over cosine squared instead. So right now I have sine squared x times 1 all over cosine squared x. And still using our algebra and using whatever we ever do with math, when we multiply fractions, we multiply straight across. So now I have sine squared x all over cosine squared x. Now we know that sine over cosine is tangent. So this just becomes tangent squared x, and that's as simplified as we can get it right there. These can be difficult for quite a few students. The biggest thing I would suggest is maybe try working on it yourself, pause the video, then watch how I do it. I've done these for years, so I just kind of have a knack for doing these, and the way you develop that is doing more. So these can be tough. There's a billion different ways to solve them. You can go in different directions than what I do, but as long as you get the same result, it doesn't matter. So as long as you're doing legal things, legal algebra things, and legal substitutions, you're okay. If you do something wrong as far as algebraically, then that's where you're going to get things wrong. Okay. So a helpful tip is anytime you see tangent squared, you're probably going to want to change that to sine squared over cosine squared. So I'm going to have v squared times sine squared x all over cosine squared x. That, for some reason, just always seems to help. It seems to get things to cancel out, especially when I'm dealing with a secant here, because I know that secant is 1 all over cosine squared, right? So here, what you need to look at, yes, this is a fraction right here, but what you got to realize is all fractions are is division. It's saying this top divided by the bottom. And especially when we're dealing with a whole fraction separated with a fraction on top and a fraction on bottom, it's a lot easier to look at it like we're dividing fractions horizontally. So like if I were to multiply these two, v squared's on the top, it's v squared over 1, it's 2g over 1. If I just combine these, I have v squared sine squared x all over 1 times cosine squared x, right? And that is being divided by, this is the same thing as a fraction bar. If I multiply these, it's 2g all over cosine squared x. All right? And when we divide fractions, it's the same thing as multiplying by the reciprocal. So we save this fraction, we change it, and we flip it. All right? So this now becomes v squared sine squared x all over cosine squared x times cosine squared x all over 2g. All right. And now when you're multiplying, you look diagonal and you cross out, just like at any other math class you do, right? You look diagonal and cross out. The cosines cross out easily, and that's nice. So I'm just left over with v squared times sine squared x all over 2g. And that's it right there, and you're done. Okay. I think I have two more examples for you. No, last example for you. No, I skipped this one. Sorry. All right. So here we go. Cosecant x minus cosine x times cotangent. All right. That could be difficult. Well, let's talk about something. Remember what I said about tangents? It seems always helpful if we change these into sine over cosine. In this case, cotangent is cosine over sine. So let's say cosecant of x minus cosine of x times cosine of x all over sine of x. Again, I'm not sure if this is going to help us, but I'm going to try it. I know it's legal and I know I can do it. So let's go ahead and let's multiply through here. Cosine x, all right, so times cosine x is just cosine squared of x. So cosecant x minus cosine squared x all over sine. Okay. Well, this doesn't really mean too much to me. Let's try to get rid of well, actually, you know what? This cosecant, if you think about it, its reciprocal is sine, right? This has a denominator sine, so let's try to make this with a denominator sine. So this, we're going to change cosecant into 1 over sine minus cosine squared x all over sine. Now, these are common denominators. So we can add these. We can write it as just instead of having two fractions there, two fractions, we can have their common denominators. We can put those together and just write it all underneath one denominator, and that's okay. So we have 1 minus cosine squared x over sine x. All right, well, 1 minus cosine x is actually a Pythagorean identity over here, and one you might not recognize easily. Each one of these identities over here actually have, have two more. What I can do is I can solve for sine squared x by subtracting cosine squared x. So I can subtract this value over, and all of a sudden I have sine squared x equals 1 minus cosine squared x. Or I could solve for cosine squared x and subtract sine x. But what my point is that this is also identity too. If I can say that sine squared x equals 1 minus cosine squared x. And all I did is I subtracted this over here. So notice here, right here, I have 1 minus cosine x. Well, what is that actually? What could I substitute in? I could substitute in sine squared x. So now I have sine squared x all over sine x. One of those can cancel out to leave me left with sine of x. So each of these actually have two more. I can subtract 1. Tangent squared equals secant squared minus 1. I could bring tangent over, say 1 equals secant squared minus tangent squared, and all that sort of stuff there. Okay, let's check on the length here. We got time to go to the last example here. Okay, last example, it says the gravitational force F on a mass m is given by the formula. All right, force equals mass times gravitational pull of secant squared x minus mass times gravitational pull divided by secant x tangent x, where g is a gravitational constant. Simplify that equation. All right, we don't want to plug in all those numbers everywhere, so let's try to simplify that thing. All right, first thing I noticed on top is I noticed that these two terms share an m and a g. So they share m and g. I'm going to pull an mg out. Now I'm left over with secant squared x minus 1. And that's all over secant tangent. All right, anytime I see something squared minus 1, I'm always going to look over to my Pythagorean identities. Is there anything that has secant and a 1 in it? If I were to subtract 1 over here, secant squared minus 1 would be equal to tangent squared. So anytime I see a secant squared minus 1, I can instead plug in tangent squared. That's a legal step. That's okay. All right, so instead of this, we're going to rewrite it. We're going to take this secant squared x minus 1 because that's complicated, I guess. And we're going to write tangent squared instead. Okay. Well, that's good because the reason that's good is now I have mg tangent squared x over secant x, right? That should have been x here. Okay, secant x, tangent x. Well, this is multiplication, so I know if anything is alike on the top and the bottom, I can cancel out. That's just like, maybe you had a common 2 in each of these in the equation like this. All right, that means you can take a 2 out of both of these guys. If you can take it out of both, you can do that. Or in the same time, if it's multiplied 6 times x over 2, you could take a 2 out and have 3x, right? Same sort of deal there. All right, so since it's multiplication, I can take one of these tangents out and completely cross this guy out because there's only one on the bottom. So now I'm left over with mg tangent of x all over secant x. All right. Remember what I said about tangent? If we change that thing over into sine over cosine, that typically helps us out. So let's make that sine over cosine. So mg, and then you know what? Let's write it like we're dividing something too. So I gotta clear some space here. Hopefully you have that stuff written down. If you don't, rewind it. Okay, so let's write that as mg sine of x over cosine x. All we did is we changed this to sine over cosine to sine over cosine. And that is divided by secant of x, which is the same thing as 1 over cosine, right? So I went ahead and changed this to 1 over cosine as well. And the reason I do that is because I noticed that this guy has a cosine, so let's try to figure out how to make this guy a cosine to cancel out. Or this guy has a sine, maybe there's someone who can make this be a sine, but I know this is very easy changing it to cosine. Ends up working out real well for us because now we have save it, change it, flip it. So change the sign to multiplication, flip this to be cosine x over 1. Look diagonally and these cancel out. We're just left over with mg times the sine of x. So that whole big equation, instead of having to plug in our x values for all of these things, now we just have a simpler equation right here. I have a lot of kids ask me why we do this. It really does improve your algebra skills and dealing with functions like that, and it helps you get used to these identities and able to simplify. And one of the biggest reasons I like it is because it really clarifies, it really points out some weaknesses in your algebra skills, which is okay. And it's good to work on your weaknesses, and hopefully we get better from that. If my suggestion for this would be to maybe try to work out these same examples without looking at them. If you get stuck, go back and look at what I did. Just so you know where we're coming from, you get a feel of this. Don't worry, you'll get some more practice in your assignment, and that all that will help understand these things. These will be tough, but you'll get better at them. Hope this helps. We'll see you in class.